touting service-oriented architecture than web services. So all we do is you're the HR guy, you put up your stuff as a web service. I'm the HR guy in New York, I put up my stuff as a web service. People worry about the basic web service interface. They're not going to be any better off because your stuff doesn't mean the same stuff as my stuff does. And sort of the developers are touting web services as a panacea of the integration, but that is, it's not true. So I think it remains a thorny, difficult problem.
What happens with Cohere at the end? So down, you sell, what do you do?
It was actually sold to PeopleSoft at very low valuation.
Does it not make you wealthy?
No, I didn't. I didn't afford this house space.
I was saying that sure where it came from.
That was not one of my more successful.
So the change in your life takes place here about that period of time. You leave Berkeley?
Well,
what's going on?
So actually, I think it was 94.
Yes, you become a professor at the graduate school in 1994.
So that's a euphemism for. So what happened was, University of California, of course, is publicly funded by the state. So the state has a financial crisis every so often. As the state has a financial crisis, so does the university. And so the university had, a financial crisis in 93 or 94, and 85% salary. So the only way to deal with such a crisis is to get rid of people. So Berkeley, the University of California also has the interesting characteristic that at least if you started in the 70s, you could opt out of Social Security and instead put the same amount of money into a private version of it run by the university. So the university has its own version of Social Security. So the retirement fund is way overfunded because it's not paying. It's a pay-as-you-go kind of system. It has good money managers. They've done well. And university faculty don't ever retire. They die at their desk. So say one pot of money was ridiculously overfunded, another pot was empty. So of course, standard bureaucratic wisdom is you just bribe people to retire. So basically in 94, the first year I was 50 and qualified. And so I said, fine, I'll take the package. So basically I retired, and a professor at the graduate school is a euphemism for that. So I did,
so we're very young emeritus.
Well, I think what ended up happening is that at the 94 crisis, there were 11 computer science faculty at Berkeley that were eligible, and 7 took the package because we're all employable. And the package was basically, if you're going to retire any time in the next 15 years, they made it so you might as well retire now. So I say, fine, I'll go do something else. So they maintained an office there and so forth. Yeah, so I maintained an office, but I was drawing a pension from everyone, so drawing a salary. And so I only taught if I wanted to. And so you could then do anything you wanted to. So starting in 94, I was a pensioner and doing other things. And continuing to work 1 day a week for Performance, and working 1 day a week for Cohere.
And they were paying you salaries, I assume, for working for those companies.
I took consulting income. Yes. So I was well paid.
Did you do any other things in those last few years that you see Berkeley other than the relational? You were working on the Cohere stuff. You were working on
I was working on an innovative. The other thing that sort of bothers me is that until very recently, interfaces to relational data, user interfaces to relational databases have been very primitive. And so I was trying to build a fancy disk system that would be database driven. And so I guess the closest thing today would be something like Spotfire. So we have a very innovative disk system. And
again, you were working while you were out there in California.
Yeah. So that was what I was working on while Cohere was doing its thing, and while I was CTO of Performance.
What makes your decision now to move to MIT?
I'll give you a couple of different answers. So are they even true? So one answer is that my wife is from this area and has a huge extended family in the Boston area, and has been lobbying increasingly aggressively in recent years to change coasts. And so at some point, in the interest of staying married, it's time to live where she wants to live for a while. So that's one answer. Another answer is there's never a good time to move, and at some point, why not try something else? Another answer is that my wife wanted a bigger house, and sort of looking at trading a $1 million house for a $1.5 million house in the Bay Area, is not my favorite thing in the world to do. So if we moved, we could buy a bigger house for next to nothing here, or we think next to nothing. So those are all various pieces of the answer.
You said just a little bit though. You got married when?
My present wife was my second wife in 1984.
And did you have 2 children?
2 children.
MIT, did you approach them? They approached you? What happened?
Well, we decided to move here, and we did move here. And And she has a large extended family, as I said, south of Boston. So it's the first approximation. I put a pin in the map through a circle of Mount Botana to outside the circle. And New Hampshire is especially advantageous tax-wise. And since I grew up here, I was still looking at birch trees. So we decided to move to New Hampshire and look around for community with schools. And so that was pretty much the decision making.
You chose to live.
So we chose initially to live in Bedford, which is outside of Manchester, and then moved into Manchester a couple years ago.
Did your house up here in the neighborhood of Coffee?
Well, actually, when we moved here, I lobbied it hard to live here full time, and my wife would have none of it because it's too far from her relatives, and in the winter it's pretty desolate here. So the basic agreement is that, as you well know, if you move from California to here, you basically trade 2 for 1. So we didn't buy 2 houses here for 1 house there. So we bought both. So we had a vacation house since we moved here.
We're going to go much more briefly because history has to do with at least 10 years old, and we're now getting within that 10-year range. You move here. You don't have another company at that point. So you start something called Required Technology. What does that have to do with? What was that for?
So we moved here, and I naively figured I'll just be here and I'll be able to network and sort of build up the contacts I had on the West Coast quickly. Of course, that didn't happen. And so I went around to all the local universities, all of whom would be happy to have a relationship, of course. And so I decided to join MIT. I think in the short run, in the long run, it's the right thing to do. In the short run, they had no database expertise whatsoever. So MIT had 0 faculty in databases, 0 courses, 0 students, 0. And so what I had to do was, at the beginning, you have a stationary flywheel and you have to sort of start to get moving. So that's taken a while. And in the meantime, it was clear that the only way to get anything done was to form an amalgam of all the other universities in the area. All of them had large database faculty. So the whole Boston area is very well. We act almost as a single research group. And so among all the universities, there's a huge talent pool. And so I pretty much have organized that. And that's been very successful.
Separate to scale. So it's not something entirely different.
So that's just Brandeis Brown, Northeastern, Worcester Polytech, MIT, Harvard, and University of Connecticut and Storrs, are all within, except for UConn, they're all within an hour of each other, and they all have database faculty. So the 8 or 9 of us at those universities, pretty much act like a single research group. We have a single colloquium series. We have joint projects among all the universities. And so it's a way to get the critical, from my point of view, is to get the critical mass quickly. And over that period of time, MIT has hired a database guy. We're starting to get database students. We're starting to get MIT-only guys. But the state is just taking a while. As I said, there's a lot of collaboration among the Boston area universities. MIT is a weird duck in that if you want to join MIT, space is controlled by the research labs, not by individual departments. So you join both a department and a research lab. And you have an academic appointment from the department, but you get an office from the research lab. So CSAIL is the main computer science research lab at MIT. And it's the joining of the Laboratory for Computer Science and the AI lab, which emerged a couple years ago, the Computer Science and Artificial Intelligence lab. So that's what CSAIL is, and that's who that's the research lab I'm officially associated with MIT. And that's the other thing we should the database is an ad hoc, and I think it's not a formal. That's what I think it's not a formal organization. Okay, good. And that's one of the big advantages of being in the Boston area is there's a gazillion universities within close proximity, and the union of them forms a powerful entity. So the Required Technology, out of the blue, I got a call from this guy saying you want to consult for a startup in New York City, and so it was a startup that I was just helping.
You started doing some other creative work now at this point in time.
So say wandering around among the universities, Stanford because of Brown is something I talked to a lot, and so we decided that the idea was that there's going to be this fire hose of streaming data. I said, well, it's going to be a revolution in sensor networks. And so the plummeting cost of sensing technology says that everything on the planet of significance is going to get sensor tagged and report its location or state in real time. And that's going to create an avalanche of downstream streaming data that current system software is very ill-equipped to deal with. So we started this project called Aurora. which was Aurora, which was sort of between Brown and Brandeis and MIT, to build an engine that would process streaming data blindingly fast. And since we were database guys, you want to invent a version of SQL that will work on real-time data as it goes by on the wire. And so again, we built a prototype that was government funded. It was public domain. We spun it off into a company called Streambase that's here in Lexington. And they're doing just fine. So I work for them.
So VC money?
VC money.
What's VC for you?
We use East Coast VCs. We use Bessemer Ventures and Highland Capital Partners.
And so that's kind of the ongoing thing with you. Then you're playing the CTO role. Okay. And C-Store, you mentioned something about that before.
Okay, so then, I don't know, one of the things I often wonder is how I come up with creative ideas, because I certainly don't get it sitting up here and looking at the lake. I get it by interacting with smart people. So in the process of doing Streambase, I wandered over to a company, back up ahead of myself. So if you look at streaming data, the basic message is that a SQL-oriented system is a good idea, but the traditional ones don't work. You're just smoking something if you say put 100,000 messages a second that you want to process in real time into a database. That's just not going to work. So sort of you say, well, I wonder where else there's an opportunity that says one size doesn't fit all, which is another case where SQL is a good idea, but that the engines that currently exist from the elephants is not a good idea. So I had some exposure to the data warehouse market both at Informix and at Required. And so over a couple of years, it unfolded a collection of ideas on how to make warehouse data go fast. And collectively, you can think of this as column stores as opposed to row stores. So the elephants are also, system monitoring and all those systems have been row stores, which means the next thing in storage is the next attribute over in the same row. And that works well on OLTP, but it turns out for a variety of technical reasons that's a lousy idea on data warehouses. And you're much better off having the next thing in storage be the same column with the next row, which is just turn everything 90 degrees. So C-Store was a research prototype at MIT. It was a column store as opposed to a row store. So we built enough of it that we could get numbers, and it's dramatically faster than a row store, like a factor of 50. And so based on that, since I'm now getting old, I said, well, let's go, instead of making this really work, let's just get VC funding right away.
Changing your model.
Well, I think part of that is that it's to build it at MIT requires big sums of money, and I'm tired of raising. It's easier to raise money from Sand Hill Road or from the VCs than it is to raise it from the government. So you might as well let the VCs, use their nickel as opposed to the harder to get money from the feds.
I think again, we come back to the fact that it's your credibility that makes that thing a lot of it as someone walking off the street.
Absolutely true. So Vertica is a column store, and the same way that Streambase is a factor of 50 faster than a relational database system on streaming data, Vertica is a factor of 50 faster than a relational database on warehouses. We also, the world doesn't stop there. So more recently, I've been looking at OLTP, and we have an upcoming paper in VLDB in Vienna next month that goes through a prototype called HStore, which is an OLTP engine, and it's a factor of 80 faster than the elephants on TPCC, which is kind of standard OLTP benchmarking. So
what does the H stand for in this case?
It turns out you do want it's horizontal. Okay, you do want to work on a row. Well, it actually is a row store. Okay. But it's also true that in the scientific market, most scientists have arrays, and those are devilish to simulate on relational databases. And if you actually have an array store, you can beat the elephants by a factor of 50 or 100.
N-dimensional arrays, or just straight
N-dimensional. So every market I look at that has any significant size, if you specialize the architecture, you can win by a factor of 50 or 100.
Even from a software architecture,
or software only. So I think where I see the relational database guys now is they're selling 30-year-old architectures built in an era where business data processing was the only thing you were trying to do, and they're now trying to extend that architecture to be everything. And in the process, they turn out to be good at nothing. And so my current complete focus is to build specialized engines that are vertical market specific, that just run circles around the elephants.
Even though it's very nice to get to the whole series of subject areas that you've mentioned in some of your interviews on the specialized areas, I'd like to talk about some of those if I could, and how that applies. You talk about text sources. Does this approach, do you think, had meaning for text searches as well?
Well, it turns out if you look at Google or Yahoo, none of those guys use relational databases because they're too slow. So that's an area where you have another specialized engine that has 100% of the market.
Let me back off just a little bit. Traffic processing, we have mechanisms and tools for dealing with if you have languages to query those things when we think of it in that form. Is there a similar set of things in the array world?
So I guess I'll give a couple different answers. One answer is, in the case of streaming data, you simply want to do stream SQL, which is SQL with some stuff added that makes it work on streams. So I'm not opposed to SQL as long as there's some other engine underneath it, and as long as you put in the stuff that you need to make whatever your vertical market is work. So that's one answer, is to preserve SQL as an intergalactic interface with various extensions for these various special markets and very different implementation engines underneath. The second answer is the text guys have no use for SQL, and they're Google-style interfaces are what everybody. That is the intergalactic standard. So you could say, personally, SQL buys you nothing in that market. In the scientific market, in fact, the science guys like the MATLAB user interface, which has nothing to do with SQL. So in those markets where there is some other user interface which is dominant already, you should just use that and have your engine directly process that stuff without SQL as an intermediary. So it varies from market.
You talk about latency and the problem of latency and how that slows everything down. The multiple steps are going into the timing issues, all these things you say are really critical in some of these applications. It's a real-time
Streaming market is a perfect example of that.
Yeah. But also in the financial marketplace, that where if I'm trying to see what's happening, because of an arbitrage or something like that.
So I think if you look at electronic trading, it's absolutely taking over. So a feed comes out of the wall, and you want the electronic trading engine computes some sort of secret sauce, which no one will say what it is, but it's basically real-time business analytics. For instance, compute the momentum of IBM on a tick-by-tick basis compared with the momentum of Oracle. If the spread is big enough one way or the other, short one and long the other. So it's that sort of stuff. And the latency, the tolerable latency between when a tick comes out of the wall and when the trade actually happens.
So the trade actually is recorded.
Yeah, and when your window for arbitraging interesting events is right now it's maybe 50 milliseconds going on, 1 millisecond. And so there's this latency war going on. And so all the people who do this seriously are getting direct market feeds because the consolidators like Reuters and Bloomberg introduce too much latency. And so speed is everything. And if you want to put something in a relational database, it takes you a second, and that's forever on Wall Street.
So in many senses, you can't afford to put things into a database.
You cannot. You've got to do it on the way.
Deal with it as it's happening.
That's one of the big differences, is that the whole architecture of relational databases is so inappropriate for real-time stream processing. And so the interface is fine, the implementation stinks. In the case of text, the interface doesn't work either, and the implementation doesn't work. So both characteristics are true, more generally. One of the things you haven't focused on at all, which is very significant, is that in the mid-1970s, there was a huge argument in the relational database research community that said, should we invent a sub-language like SQL or Quell, or should we just extend the programming language like PL1 with database stuff? So there were proposals from both camps. So there was Chris Tate wrote an extension to PL1, and Jakob Schmidt did Pascal R, which was some relational extension to Pascal. So the sub-language camp won, but it's created things like ODBC and JDBC, which are devilishly difficult to use. So if you want to run a single query from JDBC or ODBC, there's this much code. There's one SQL statement and all this junk to get stuff in and out instead of cursors and sort of interface issues to the programming language. So I think the right thing to do is to do language extensions that are language specific, because that gives the programmer a much easier task. So, like for instance, Ruby on Rails is one example of a recent system that does this, which is it has database constructs that are embedded in the language. So it just makes it much easier to program.
Let's take a look at the moment. You speak to the need for better programming languages. One of the comments I've made is that over the years we can see the improvement in price performance in semiconductors. We can see it in database storage devices. We've never seen anything comparable to that in the programming world as far as I'm concerned.
In 30 years, maybe in fact.
How about 15?
Yeah, so
I've been programming from 54 on, and they tell me there's not been a dramatic change in the design capabilities or in the programming capabilities as far as I can see. It's better, but not a hell of a lot better. And I guess my question here is, there things that you can see in the way of development tools, ways of changing that, a way of making significant 10-to-1 changes there instead of the 2 or 3-to-1 that's always achieved?
Very interesting point. So one simple